What we move on next with is we're going to start looking at a couple of different ways to search. And then after that, we're going to get into a couple of different ways to sort. Well, what is it we're searching? What is it we're sorting? We're sorting a list of data, okay? A homogeneous list, to be more particular, meaning that all of the items in the list are the same data type. These are all integers, okay? Eventually, we're going to look at records. These could be all structs, different types of things to work with that we could store inside of here, but they're all going to be the same data type. And we're going to look at two different ways to search today. If you did the code listings, you should have a pretty good feel for what's going on. But the two different ways, which one is faster? You know, when you get into CPS 162, you're going to talk about something called big O notation, which tells you the efficiency of code, tells you which one is going to be faster. Well, I know if I start taking a look at this list and I say, is the number 28 in it? You're probably going to go, no, 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 no. And that was the worst case. The worst case, it wasn't there. So when we analyze something like this, we're going to go by worst case scenario. So if this is a size 12, I had to go through all. If it's size 2000, we got some other issues. But for now, we're going to take a look at how would you go through a basic linear search. Well, let's see. If I said the number 6, I would go, no, 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 yes, and I'm done. My other one was 28. I went all the way through and couldn't find it. So as I'm doing like test data in my head, I'm thinking, all right, so I had to look for 28, not found. I have to look for 6, and it was found. So there's two ways this process would end. This is something to start thinking about, to build on. You know, I'm getting ready to start this. I'm walking through some test data. My two choices are whether it's going to be found or not. So if I was to write some pseudocode for this, I'm going to start out by saying input a num. And what else? What is my goal here? To see
I
what?
know.
You don't know? To see if the number's in the list or not, right? So now I'm starting to think about, I did my input. Maybe I ought to jump down and see what is my final goal down here? What is my output? My output is to display that I either found the number or I didn't. Maybe this is some kind of function where I would, if it's written as a function, I would write true. Well, what would be the advantage of writing this as a function? Copy and paste.
So you can pass values, arguments.
Mm-hmm. But I also may be writing another program later and go, no, wait, I already wrote the linear search. I can now use what I already wrote. And if it's a function, it'd be easy to go and copy and paste. Okay. If you want to do it multiple times, it makes it nice as well. All right. So I'm going to input a number and I down here, I know I want to return something. This is a function. What am I going to return? Good. We'll return a
Uh,
Boolean. We'll return a Boolean called found. And found will be either true or false. So up here when I input number, I might declare a variable called found and give it an initial value of what?
False.
False. Okay. I can give it false. Could I make that 0 if I wanted? Could found be 0? Ryan says yes. Yeah.
Yes.
Yeah. Okay. So now I need to get in here and I'm going to have to loop around until it's either found or not found. Sounds like a loop. While, parentheses. How many conditions do I have? 2. Tell me what to write.
uh, exclamation found.
Okay, so that'll make that a true. Ah,
We'll also need
And
I hear ands.
we'll need an index to check that we're not outside of the array.
Okay. I heard the word index. Start index out at what?
0 or
Zero.
1.
And again, we can always leave that blank and go back and, yeah, so it's either founded or, so not found and I'm guessing you want
You're-
index because somebody just said index.
Index is less than size.
Index is less than size. Again, that's something that makes me nervous, but that's something we can, oh yeah, we already have size up here declared. We have array num already declared. And, okay. What's it look like inside?
You want an if statement
Yep,
with your array at the index equal to your value, or checking to see if it's equal to the value.
if it equals num,
Oh yeah.
okay, then what?
Found equals true.
Found equals true. Anything else?
And increment index.
Thank you. Initial value. Check. Increment. All right, is that solid? And again, you typed in code listing, Hooja Mahooja, whatever it was, 8.1. And I think that's what it was. So if I went up, I don't have it up. Does anybody have it close by? They can throw it up on the screen, see how close we were. While that's happening, we're going to talk about index. Index is an old school term. Okay, a lot of times in loops, you see for I equals 1, I is less than 12. Well, that I comes from index. So if you see index or you see I, that's a little bit of an old school programmer coming back. I'm guessing at 8.1, that's what it says.
Yeah. Yep. That's right.
Do we have it? Dario, not yet. That's the next program. Oh, I guess I have to grab the book.
Yeah, I have a professor if you want me to show it.
Yep. Thanks, Ron. Do, 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 do. All right, so now we have it as a linear search array. We bring in the array, we bring in the size, and we bring in the value we're looking for. This guy actually returns the position of where it might be found. We were just doing true or false, something a little bit different. But I see while index is less than size and not found. So yeah, I don't know if whoever suggested index stole it because they remembered it, but that's absolutely fine. And I have my array found equals true, and we do index plus plus and questions. Because line 39 is my index plus plus. So if found instead of found true, we'd have to have a position as something as well. And we could return that position. Thanks, Ryan.
Yep.
Okay. The second type of search goes back to an old school game that used to be on The Price is Right, where they'd ask the price of something and the person would go $600 and then he would go lower. So they would go $500. He'd say higher, and then they'd start doing something like 501, 502, 503, 504. Oh, yeah. So it went from this idea of being a binary search into some sort of linear search. But the difference in the two to start is this list has to be sorted. So if I was to read in a list of numbers like I had over here, I could go right into the linear search. If I read this list of numbers in before I could do the binary search, I'd have to incorporate some sort of sorting algorithm. And on Thursday, we're going to start looking at 3 or 4 different sorting algorithms. Okay, ways to sort a list. So assuming if I want to do a binary search, first thing I have to do is sort it. Okay, so this goes back to a program you did for me 1 semester ago in CPS 121, where there was a guessing game and you had to enter numbers between 1 and 1,024, and then the computer said higher or lower. All right. So why did I pick 1,024? It's a kilobyte, right? Yeah, it's kilo. It's got kilo in there, but it is also 2 to the 10th power. And being 2 to the 10th power, that means if I use a specific strategy, I can guess this number in 10 moves. So instead of going through 1,024 being my worst case scenario, if I had a list of 1,024 numbers, my worst case scenario with linear would be all 1,024. But if it's a sorted list and I use a binary search, I'm able to find it in just 10 moves. So I should be able to find it in 10 moves. Whoa, no way. Yeah. And this is where that half it method comes in. So for example, if I pick a number and it's between 1,024 and I pick 512, that's dead in the middle, and they say lower, I just eliminated half the numbers already. It's lower. My new range now becomes somewhere between 1 and 512. What number am I going to guess? Halfway between those two, which is 256. If they say lower, I'm now going to look in the range from 1 to 256, which means I've now eliminated 768 numbers. Within 2 guesses, I've just eliminated 768 numbers. So by using this strategy where I keep cutting in half and I can find out higher or lower, I'm quickly eliminating 512 numbers. Then I eliminated 256 numbers. You all know what the next guess should be, right? 128, higher or lower. I just eliminated another big group of numbers. So if I threw out this array that there's 12 numbers, how many guesses should you be able to find this in?
Four.
4 guesses, right? Because the next highest power of 2 would be 2 to the 4th power. So we'd have to include it. So within 4 guesses, you should be able. So my lowest number is 1, higher number is 12. What number do you pick?
6.
6, right? Your first guess should be 6. So in honesty, when I'm grading those 1,024 programs, I go in and chop off the 24. That way I'm able to count the number of guesses a lot easier. So then I just work with from 1 to 10. I pick 5 and then I pick 8. And so it takes me within 4 guesses as well. So I don't have to spend all day trying to guess the programs, right? So let's see, I have 1 and 12. And how did I get to 6?
By dividing 12 by 2 to get
Okay.
the middle.
I heard dividing 12 by 2. So I read this number as 6 and I said higher. Now what's my range of numbers?
6 to 12.
6 to 12. How do I get my next guess? Guess. What would the next one be?
9.
How'd you
9.
get 9?
It's in between 12 and 6.
Algebraically, how did you get
Uh,
9?
6 divided by 2.
A little bit more,
You
Dario.
add 6 and 12 and then
6
divide by
plus
2.
9.
6 divided by 2.
Divided by 2.
6 plus 12, integer division 2. Okay, that's going to give me 18. I cut it in half. So I'm going to work with that integer division because I think it's gonna, well, I know it's gonna give me all the numbers that I possibly want. So it's between 6 and 12. And the next guess is gonna be 18 divided by 2 is 9. If I said, I'm gonna keep going here, it's lower than 9. So what's my net, it's lower than 9. So what's my new range of numbers?
Plus 9 by
6 to
2.
9.
6 to 9. By this idea, I'm going to add the two numbers together, which is 15 integer division 2 gives me what?
7.
7. So I'm going to guess 7. And if I say higher than 7, I add 7 to 9, cut it in half and get 8 would be, yeah, and so it's going to actually be able to hit all those numbers. If I said it's lower than 7, we would go between, and well, we would have actually guessed it up here because it would have been 6. So by doing this in integer division, going higher and lower, I will hit every number, which is a possible concern when I was going through there. Okay. So if I took a look at this and I said, you know, when testing, what numbers am I looking for? So test data, what numbers am I looking for? I'm looking for 2, because that's before the list. 4, that's the very first item in the list. 36, 70, 72. Give me one more number that should be in there. One more test data item. So this is before. This is after. This guy is the first. This guy is the last. This guy is the middle. Give me one more number that I might want to check that I'm searching for. So if this becomes my future test data, I know what all the numbers I want to check to see if they're there. So that's before, that's the first thing. That's one in the middle. That's the last. That's after the loop. Give me one more item and number and why.
35, since it's not in the array.
Excellent. 35, because it's not in, but I would get kicked out. So yeah, I'm going to have to make some room in here, and I'm going to say 35 as well as 36. And my 35 is not there. So if I was doing a program, and you know, we continue to talk about test data, these are definitely the numbers I'd want to test to make sure it works. Questions?
And this is only for sorted data.
This is for sorted, that's correct. So again, does it take longer to go through 1,024 numbers if I had a linear array that's really big? Or is it faster to take the list that came in, sort it, and then use the binary search where I'm only checking 10 numbers? But I have to do a little algebra in there as well. Questions? Okay, what I'd like to do now is, I know you've already seen the, from the code listing, you've seen the binary search. That was code listing 8.2, correct? You typed it
Yes.
in?
Yes.
What I want you to do is I'm going to put you in groups, and I want you to spend about 15 minutes without looking at the code and see if you can come up with an algorithm like we did here. And we want the algorithm to make sure it works for all of this test data. Okay, so the next thing we're going to do is we're going to move on to the next section. We're going to leave linear searching and binary searching, and we're going to start taking a look at sorting techniques. So again, we're going to work with that same list of homogeneous data, and we're gonna have a key field. You know, the examples we're looking at is just a single value inside of here, a single value. But we would have a key field that we would search on. We need to talk about some terminology. Ascending is 1 to 9. We're going up. It's A to Z. Descending is going down. 9 to 1, Z to A. 99% of the time, you're going to want to use ascending, but we need to make sure we have the terminology. Conceptually, there's 3 types of loops we're going to take a look at, or sorting. Selection, exchange, and insertion. And a quick overview is selection will be where I go through my list, I grab one item, and I move it. Exchange, I'm going to be doing lots of little swaps. Insertion would be like if I was dealing you a deck of cards, you'd pick a card up, then the next one you would insert it right into the spot it needs to go. Then the third one comes in, you would go and insert it right away. So you're sorting it as you're inserting the data elements. All right, so the first one we're going to take a look at is one type of exchange sort. There's lots of different types. You're going to do sorting here, then you're going to come to 162 and go, oh my gosh, I didn't realize there were this many ways to sort items. And a big part of it is how we store our data. Here we're storing it in arrays. We'll look at other ways that we can store down the road, other data types. So if it's an exchange, I'm going to be swapping, okay? And I'm going to keep track of swapping, and the way I'll keep track of it is with using trues and falses. How are we going to go through this? We're going to compare the 0 position to the first position, 1 to the second, 2 to the 3. And if they're not in ascending order, I'm going to swap them. Okay. And I'm going to keep going through this loop until there are no swaps. So for this guy, I need a do while loop, and I'm going to use a for loop. There's going to be 2 types of loops. And just a side note that this type of sorting, this bubble sort, is bad for large sets of data. So I'm going to go through the list the way you see it. And we have 4, 14, 8, 9, 20, 38, 40, 24. I'm going to stop there. I don't want to keep going. And I'm going to go through and do a bubble sort. So again, I'm going to say, okay, I'm going to compare 0 to 1. Are they in order? Your answer would be
Yes.
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 Now I'm going to compare 1 to 2. Are they in order?
No.
No. So I need to swap them. And because I swap something, I'm going to keep track of that. So after I go through this entire list, I'm going to say, okay, so I'm done with that. I did a for loop from 0 to here to do all of these side-by-side comparisons. And when I'm done, I'm going to say, did you make a swap? And if the answer is yes, I'm going to do it again. So this do loop is going to be outside of the for loop. All right, so I would keep going. 14 and 9, yeah, they get swapped. 14 and 20, no. 20 and 38, no. 38 and 40, no. 40 and 24, yes. So kind of what happened as I went through this is some of these numbers that were smaller start to bubble to the front, while the largest in what I looked at actually bubbled to the end. Going through again, because I did swap. 4 and 8, no. 8 and 9, no. No, 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 nuts. I did a swap. And no, since I did a swap, I go through again. 4, 8, 9, 14, 20, 24. Do all those side-by-side comparison and pow, it's all good. All right, so let's start on the inside and work our way out. The inside was this inner workings where I'm comparing, and what do I have here? 2, 4, 6, 8, 10. I have a size of 12. I have a size of 12. And I'm gonna do my inner loop. What does the inner loop look like? Well, I'm gonna compare 0 to 1, 1 to 2, 3 to 4, and 10 to 11. I even have an 11 written there. So give me a for loop to do this. Where would I like to start it? Because I'm going to start it and compare the 0 to 1. Then the next time through, I'm going to compare 1 to 2, then 2 to 3, then 3 to 4, 4 to 5, 5 to 6, 6 to 7. So my last time through would be 1 before the end.
So that would be from 0 to the size -2
Okay.
or
size-
-1
oh,
less.
yeah, I'm okay with that. Less than size,
-1.
so I want to go to 10. So size -1, I think is going to work.
And then
I'm going to come in and I want to say in my if statement, what? This guy,
array index
array num, because these are numbers, sub
Greater.
counter.
if array index is greater than
If it's greater than
index plus 1, array
Yeah.
index plus 1.
array num sub counter plus 1, then stuff happens. And what happens?
Swap.
I'm going to swap. Let's see how swap works. If I have A, I have B, I have temp. Right? A is 4, this is 6. I'm going to let temp get the value of 4. A, which was A, right? A is going to get the value of B, because this one over there, that was first. Now this is coming over here. That becomes a 6. And then B is going to get the value of temp.
Is temp like a placeholder?
Yep. It's just a temporary variable. It's going to hold an int temporarily while I move the other one over, and then it can move it in.
What happens in the end? It's no value.
They switch places. And then we're done with temp.
Okay.
So if it's greater than, I need to, first of all, swap them. So let's see, temp would get the value of,
A.
okay, but up here it would be what?
Counter.
Yeah, array num sub counter. Keep going.
And then array num counter equals array num counter plus 1.
Good.
And then array num counter plus 1 equals temp.
There you go. So we swapped them. Is there anything else I would need to do inside of here?
Swap. It should be a swap equal to
Yeah,
2.
I'm gonna have to say swap equals true. Which means I'm going to, oh, I'm crooked. I apologize. It's my camera. There we go. Which means I'm going to have to have a swap variable up here. What should I set it at?
Bool.
True.
Set it as false. So what's my do loop gonna be here?
Do
Do,
what?
do
Swap
this
this two.
while swap equals false. All right, so if I set it as false up here, I come in and it does all this, and if it was true,
Shouldn't be
I
true.
think it should be while swap equals true, right?
while swap equals true,
Because if it did swap, then you
Okay.
can do it again.
but I need a swap up here. So if it is true and I swap something, when I come back up to my do loop, what would I
You need to
almost,
assign,
what would I need to do first?
you need to assign swap to false in the
Yeah,
beginning of the do
so
loop.
maybe I'm even gonna just do something like this. And here's my do. And the first thing is, oh, not false, but swap equals is assigned the value of false. So right now swap is false. I come in and I go through, and if I do make a swap, I turn this to true. While it's true, I go back up and do it again. Looks pretty good. Looks pretty good. Okay, so what I'm gonna do is I'm gonna put you back into your groups. I want you to fill an array with values. Look something like this. Do it implicit. Do it implicit. Then I want you to write two functions. First one is called display, which will display your list. The second one is called swap, which you'll then swap your list. And then you can go back and display it again to make sure it's good. So your main will be display, swap, display. Your prototypes will be for just two functions.